All right, so let's get going. With me on the call today are some fellow MVPs who themselves specialize in app development and data and AI. A little bit about Azure Sketches. It's an original concept. It's a creative beta concept that we're trying out, which is designed really to invoke visual senses and to help you walk away in a power hour with some valuable design principles. This session is for budding architects. The session is for experienced architects. And the session is really focused on helping you become a better architect, and it applies to myself as well. It's about sharing. It's about best practices. So a lot of what you're going to see today comes from a lot of the information, right? The best practices. It comes through various forms, but mostly from what we find works in the field, right? It almost always aligns back to documentation, MS Docs, but not always. The format is unique, and for the most part, we will use traditional drawing and sketching to help with understanding the content. I'm really hoping you guys enjoy the session, and your feedback will allow us to continually improve the session, the content, and the creative styles as well. So please ensure that you provide real feedback on the meetup group. So before I begin, I have a fellow MVP who's presenting this week. His name is Niels Berglund. He's from Durban. He's a data and AI MVP. Gordon Beaming will post his session this week. I think it is on Thursday. So please try to attend that session. So coming back to today's session, today we're going to focus on 7 principles of good cloud design that I find works very well. It is by no means an exhaustive list of principles, but I believe if you stick to these 7, you'll be in good stead as an architect. I'm going to keep the session fairly high level, right? We have an hour. Keep it fairly high level for today's discussion, and we will increase the skill level as we become more accustomed to what works, and that we become more accustomed to yourselves. Feedback is very important in these sessions so that we can continually improve them and make them more engaging. Now, I'm hoping that a lot of you have some level of Azure experience or expertise. If not, I'm sure you will at least understand the concepts through the drawing and the sketching. After taking you through these principles, I'm going to fly through these principles. I'm going to switch to a sketchbook, and I will show you. I will take you through my design process. Sometimes it's in a piece of paper, sometimes actual sketches, and then I'll work my way onto a complete production-ready design or blueprint. Now, we'll go through the entire design process, taking into account all of these principles. But like I say, what I want to do today is focus on 2 principles because it's impossible to cover all of these. But I'm sure all of you relate to these 7 principles. All right, let's go through the first one. Subscription and resource management. Now, managing Azure can become a nightmare if you start poorly. For the most part, you cannot change things after something is deployed. So design for cloud is crucial, and getting your subscriptions right at the outset is very, very important. You need to know how many of each, you need to know when to create more, and you don't want to be stuck with a mess because for the most part, like I said, you can't change things. Subscriptions are like folders where you place resources. It's an organizational and a billing unit. Subscriptions are tied to an account that you will have with Microsoft, which is a billing unit or an enrollment. It is also an organizational semantic upon which you can define, governance and resource-based access control. I'll take you through that in the schematic so that you understand where it fits in context of everything. A tenant is a directory, just so that you understand where a subscription fits in versus where a tenant fits in. A tenant is essentially a directory that houses your user accounts and your application artifacts, and it's really the primary unified source of identity. Resource groups are folders within the subscription into which you place your resources, and they are usually containers for specific projects. Now, that's all fine and good. What I want to do today is take you through when to create subscriptions, when not to create subscriptions, how to define your resource groups, and especially for accelerated design principles, or especially for accelerated design, you want to try to stick to these guidelines, right? You got to keep your subscriptions down to a minimum. And it needs to be designed for organizational or operational efficiency. What that means essentially is if your organization is geared for a departmental styled management, then your subscriptions might be geared to that, because the whole workflow of the organization and the billing and the cost management will fit in nicely. So your subscription design is really tied to your operational and your organizational efficiency. Subscriptions are also used as, this is my terminology, you need to design for gated cost estimates. What that basically means is that as you're designing for workloads and as you're designing for projects and resources, you always do a cost estimate up front. Even if it's a dev workload, even if it's a POC, you do that up front. You must always understand subscription limits. If you assume that your subscription, you're never going to run into those limits, you may want to decide to split prod and non-prod, for example. And just understand and just remember, a subscription is a billing, it's a cost and a governance boundary. What that essentially means is that billing wraps itself into a subscription and it feeds back in. From a cost perspective as well, you can easily articulate a business unit if they're assigned to a subscription, and you can also deploy governance controls down to subscriptions. Just remember that, right? So when I get into the sketching and the drawing, you'll see what I mean. The benefits are keeping it to a minimum, design for operational efficiency, and use them for, when you're deploying your workloads, have a subscription dedicated for play penning. Understand what your limits are. Don't underestimate them. I'm going to fly through this because this is not one of the principles we're covering today, but it's one of the 7 principles. Governance, compliance, and identity. I wrap those up into one pillar. It's the second principle, and for me, it's the cornerstone of your design. It basically controls who has access to what resource, and also what you can do with the resource. So this is critical when getting this right. Governance defines freedom through guardrails concept, which means that you want to give your organization freedom, but you want to ensure that you have a fairly defined guardrails, and that you do with the governance pillar. Define your governance and regulatory controls up front. I'll take you through some of that. And usually the governance and regulatory controls are usually defined in blueprints or Azure blueprints. That needs to be defined up front, or use existing or customized blueprints. Essentially what that means is that your entire estate, your Azure estate, is locked down even before a person spins up the first workload. Infrastructure as code or automation is key to this pillar as well. So, as you go on your cloud journey, ensure that you have automation as a key pillar, whether it's using Azure DevOps or whether it's using where your operational tasks need to be automated for operational efficiency. Very important from an identity perspective. I haven't spoken much about it. This is another session. Identity in this day and age is the primary security boundary. It's not the network. The network is no longer the primary security boundary. In this day and age, with the devices that we have, with the applications that we have, everything somewhere along the line comes from the cloud, and therefore you lock down that security bound. Same with Azure. Azure's identity is Office 365 identity, or should I say Office 365 identity is Azure identity. Now, this is one of the two pillars, the two principles I'm gonna look at today, because I think it's interesting to almost everybody. The third principle is how your data flows in and out of your cloud estate. Almost always you require connectivity between on-premise and the cloud. This is such an important design principle to stick to, right? The network is the fabric upon which your users will transact seamlessly with your ecosystem when it's fully operational. And what I want to, 99.9% of customers get this wrong. If you get this wrong, you're in really a deep heap of the proverbial. So some of the things we're going to look at today, you can use network routing as a security mechanism. So you route by exception only. What does that mean? It means if you have an on-premise network connected to the cloud, you don't connect the entire cloud to your on-premise. Your network and routing appliances or services like your gateway service in the cloud should be a PaaS service. You can easily switch to using virtual appliances, but use PaaS services by default. They're efficient in terms of cost. They're scalable, and it's obviously not. You don't need to manage it, or you don't need to worry about the scaling of NVAs, for example. Point number 3 is critical, right? When you are building applications, you get your network wrong. It's easy to just create one big, massive /16 network, and then each individual application is sitting on a subnet of that big VNet. That is extremely dangerous, and I'll take you through how you actually do it. Do not use subnets as separation between workloads. If you want to connect a workload in the cloud to on-premise, you use the hub and spoke peering or spoke to spoke. Use the hub and spoke peering. If you want to connect an application to another application in the cloud, you use the spoke to spoke peering. Minimize NSGs. NSGs are a pain to manage. So this is the one principle I'm going to look at today. I'm trying to get to the sketching, fairly quickly. The next pillar we're going to look at today, right, is security and isolation. Security for cloud is in most cases a reason not to go to cloud for a lot of customers, and often enough it becomes a reason for companies that want to move back from the cloud because they didn't get the security right. Security in the cloud is not a magic bullet. It is, you need to stick. There's a lot of dials as if you're flying in a Boeing 747. You need to know what the controls are, and you turn those on. Same with the cloud, right? And what I'm trying to help with the Azure Sketches section is to try to help you guys with, some of the ground that we've already covered, so that you don't necessarily need to make the same mistakes, and you can apply these to your design philosophy. Restrict public IPs, guys, from a security and isolation perspective. These two pillars are, and governance, but these two pillars are really, really critical, and you really need to think from a future perspective to ensure that you have enough IPs and to ensure that you do not have one leaky public IP somewhere on a resource that's connected to your on-premise network. What you will have is you could potentially open yourself up. So philosophy, rule of thumb, restrict public IPs using policies or blueprints. Means categorically, if anyone tries to spin up a workload with a public IP, it will reject. It will not allow that resource to be spun up. I'll take you through how will you allow ingress and egress into your cloud. So you obviously want to ensure that services in your cloud that you are publishing to the external world have some way to get into your resources. And then you want to obviously control egress and ingress to your on-premise. There's a way to do that. And the way to do that is not to have public IPs on your virtual machines, for example. Even though you may be the best person to manage those subnet NSGs, someone always forgets. An interesting one, point number 4, which you'll only really understand when I start getting into the drawing side of things. Traditionally, if you wanted to connect your on-premise into the cloud, you have to have a gateway and you have to have a firewall. And that's fine and good. But then as you start scaling, it becomes a challenge when you're connecting multiple networks and remote sites, and you are now connecting them into other virtual networks in the cloud. Using a combination of Azure Virtual WAN and the concept of an Azure Security Hub, which is a product in Azure, what it does is it takes the virtual network gateway and it combines it with the Azure firewall. So it becomes a PaaS service. So you don't see the gateway, you don't see the firewall, you manage the rules. You essentially manage and it obviously has got dynamic routing built into it. So if you plug in a virtual network into the Security Hub, routing automatically happens to the sites that are connected into it. And this is an interesting one. Like I said, do not create big VNets. Do not create big VNets into the cloud. Do not create one big VNet for the future of your cloud journey, and then hope to separate those into multiple subnets. It is possible to do, but it's very difficult to manage from a security perspective because every subnet implicitly has routing to every other subnet. HA and DR, I'm going to fly through this. Availability of applications, right, is always confused with disaster recovery, HA. It's not the same thing. HA is your application's ability to continue running seamlessly during equipment, hardware, in some cases, application failures. Even your application doesn't really need to have that built-in capability, but the infrastructure that it's on, as you design it for Azure, can kind of give it that capability. So for example, you have an availability set or use an availability zone. So you never put two instances of your application on the same, well, Microsoft won't do it for you. So if you don't implicitly say use an availability set, it could happen. You could have two instances of your nodes sitting on the same physical machine. Disaster recovery is a very specialized area, right? It's really used under extreme conditions, loss of a region, loss of a geography, loss of a data center in the traditional sense of a data center, act of God conditions, and which do happen. What you need to do here is when you're planning for HA and DR, not everything needs to have full comprehensive DR. Look at your workload requirement and make sure it's workload requirement specific. Understand your application's profile for state. What that basically means is that if you're doing DR and you're doing active passive configuration or active, you can't really do that if your DBs don't allow for real time, like Cosmo DB does, right? Active multi-writes. You've got to consider that. So don't promise clients that they can get active configurations. Look at your DB, look at the Azure services that can allow that. You more than likely will have some sort of very small RPO, not necessarily zero loss on RPO. Philosophy across all services, use PaaS services, built-in capabilities. Keep things simple and automated when it comes to HR and DR, irrespective of how complex your application is. Using failover, Microsoft gives you, or Azure gives you the capabilities to program that in, what to do when there's a failure. A traffic manager will detect that an endpoint is down, traffic is routed to the second instance, and then you can have recovery goals that can now run automated tasks as required. So basically what this is once your services are running and they're operationally running, you want to be able to manage threats and performances with intelligence. It's really what it means. You want to do log collection from inception, use PaaS services. The key for threat and performance intelligence is really don't focus on the infrastructure to collect it. Focus on the data you want to see to make the right decisions. It's like the analogy is it has the ability to invoke pattern recognition and AI to see traffic slow down in front of you, even when you don't have line of sight. It recognizes the car speed in front of you as an example, and your vehicle then takes the appropriate automatic or manual mitigation. Protection and recovery. This is not HR and this is not HA and DR. This is backup and recovery. Do not go overkill here in this pillar. What you need to do for this is decide what data is critical, what changes, what is high churn rate. Protection frequency, recovery point frequency depends on your business requirement, right? If something is not changing a lot, or if data is not important, then you don't necessarily need to take a recovery point every 15 minutes, because all of those things have overheads on them. And even in Azure, you don't really want to, if you're trying to get down to a low RPO, recovery point objective, it comes with a cost, a penalty. Also, archival data, yeah, it's cheap in Azure, but over time can become expensive. That's not just for Azure, that's for other clouds to manage that and use hybrid storage technologies to move offsite data. Guys, don't worry that I'm moving very quickly through these sections, because what I want to do is subsequent sections, we will unpack each one in much more detail. So let's get into the design. I'm switching to tablet mode. All right. So like I said, guys, I'm taking you guys through some of my design processes that I use, and this is what I usually start off with. Ironically enough, I actually start off on pages. So if I have a design to produce, what you see in front of you is all the fundamental building blocks of what we discussed. So, for example, the predominant pillar, right? Remember I spoke about governance and identity. This is the pillar that you need to cater for yourself in the design, and this is not something we're going to focus on today, but I'm just going to give you an indication as represent where the elements actually sit. So this is Azure Site Recovery, right, and backup. So even though it is these fundamental blocks and these fundamental pillars literally is what you need to be starting off with, because it gives you a visual context of where things, where things are actually represented and how you're going to be designing. And what we have here, this section, basically at the bottom here is a multi-pillared threat intelligence. So what we have here is the log analytics portion that I spoke about. Right, and this is the whole concept of monitoring, whether it's threat or performance monitoring in Azure. It's the philosophy of collecting logs and doing it very efficiently, and then to apply pivoting techniques, whether it's another product that comes along like Security Center. And what that does is it benefits from the log collection. It's a separate technology, and what this is best practice in maintaining your security. And then what we have is Azure Sentinel, which is basically the AI-based threat intelligence that I spoke about. All of this is multi-layered, and this whole section here, and what'll eventually happen is you integrate into an organization SIEM, right? It's always flowing down. And in here is obviously Azure Monitor as well. And you need to cater for this in your design philosophy, right? And all of these pillars, they all relate to each other, and they're fundamental, very important in ensuring that you comply with the Cloud Adoption Framework, or the CAF framework. Right. Like I said, what I want to spend the rest of the time doing now is I want to talk about the network and the security, and just covering some of those caveats that I spoke about. So what we have here, right, is the on-premise environment, right? And the on-premise environment is usually made up of some sort of service provider, connectivity, whether it is Liquid Telecoms, Vodacom. That's always the case. A lot of that equipment is sometimes stored on there's always a local footprint, but there's always, like for a layer 3 network, you route back into the service provider's network. And then what these things are, right? Coming back to the subscriptions, remember I spoke about subscriptions. So these blocks here that you've seen, these blocks here, right? These are subscriptions. And you see how it relates to the three core pillars, which is governance and threat and performance analytics and backup and protection, right? They're kind of like almost encased inside of those. And each of these three core pillars, they basically help to control, secure, lockdown, and control those resources. And so what we have here is the number of subscriptions. Now, you remember I said keep subscriptions down to a minimum. If you go with the absolute minimum in terms of subscriptions, right? Absolute minimum, what you're going to end up with is subscription called Hub or a shared services subscription, right? I'll explain what that is in a minute. Then you will have a production subscription. You could, like I said, split this up into prod or non-prod, but that's if you're reaching your limits on your. In most cases, you wouldn't. There's almost always a development subscription, and what we have is a QA subscription. You might have another one, Playpen. If you're a large corporate, large enterprise, you'll see this. You'll see this expand, but I've even seen very, very large organizations stick to this. The more subscriptions you get, the more management you need to maintain, and it gets very complex to manage resources, right? And what we have inside those blocks, the square blocks that are inside that, those are resource groups, right? So for the shared services in the hub, what I always do in my designs, right? What is the shared services subscription used for? So firstly, it's central. Remember what I said, central egress and ingress. Egress is going out, ingress is coming in. So all traffic, right? All traffic to and from prod, dev, and QA has to transit this hub services, shared services subscription. You do not want to have, when I do the drawing there, you do not want to have workloads that break out at their subscription level under any circumstances. So what you would have here, it's also good for management, and as the name suggests, shared services. And I'll draw what I mean by that now. All right, so what we have in front of us now is we're starting to layer on this design, right? And we're starting to see it come together. So what does the networking look like? So let's just assume that this is a scenario. So what we have here is the on-premise environment, and the on-premise environment is a 192.168.0.0/16, right? Some of you will have multiple blocks. And then what we have, and this is where, if you recall what I said, remember what I said, now, if you have the shared services there, and you have prod there, and you have dev there, and you have QA there, you're going to have multiple workloads, right? A lot of them will require virtual networks. Now, how do you manage these virtual networks, right? So what you could potentially do is create, let's just say the customer has chosen 10.200.0.0/16. Right, that's a cloud block. Now, what you can do with this scenario is to be lazy, right? And then say, remember, VNets can't cross subscriptions, right? So what you'll do is you'll take the /16, you'll break it up in like 1, 2, 3, 4 ways potentially, or maybe the production will have slightly bigger. And then you'll have a massive virtual network in each of these prod, dev, and QA. And the problem with that is you have workload A. So this, let me give you some context here. This small block is shared networking. That's a resource group, right? In Hub Shared Services, you're going to have a shared networking resource group. And you potentially are going to have other resource group like identity, or where you would or shared services like key vaults, anything that needs to function on that subscription. Certain services can't cross subscriptions, right? Same with every other subscription, right? So what you'll do is you'll start off with a shared networking resource group there, and a shared networking resource group there, and a shared networking resource group here. Guys, by the way, you can actually define a blueprint that once a subscription is ready, you target the blueprint. So you can actually define a blueprint that goes and deploys all of this without you going manually and configuring any of this. But essentially, you're going to have a shared networking resource group on each subscription. And then now if you go to prod, right? So prod, we're going to have an app1 resource group, whatever you want. And let's just say we want, in this one, we want an app1-dr resource group. Remember, subscriptions are not location specific. So this could be ZA West or CT, and this is ZA North, right? So these workloads will reside in the same subscription. And so on the development side, you have the same scenario, right? The naming convention might change, but you'll have app1, and then you'll have potentially app2 in that resource group. So we're going to leave the QA out, but you get the picture, right? And what you want to do in the shared networking is, before I get there, let's just look at how we connect the on-premise now into the cloud. So every network has got two environments, right? So they've got an internal network. Now that might be multiple VLANs, and then you've got a DMZ. Some organizations have multiple DMZs for shared services providers, or an MPLS into another vendor. And there's almost always a firewall between the on-premise and the DMZ. And let's just draw some servers or desktops or whatever that is, split into different VLANs. And now we get to the service provider. Let's just say we're connecting an express route configuration. But before we go there, in the DMZ, right, you'll have another firewall. Now this firewall is like controlling breakout, internet breakout, or service provider breakout. You're controlling an express route breakout. And in the DMZ, you potentially will have, this is your on-premise network, right? Remember, that's an on-premise network. So you'll have, you potentially would have a proxy server or whatever services that you want in there. So now if you want to connect the express route, what you'll do is express route configuration almost always has something called local edge routers and Microsoft Edge routers, and these are resilient, right? As you can see. So an express route is always resilient. We're going to go for an express route, but I'll show you what it looks like if you want to connect an IPsec. That's pretty much at a very high level what you would need to connect your internal network to the DMZ. And I'm simplifying this in an amazing manner, when in reality, there's a lot of specialized IP block routings and BGP that needs to be configured. On the Azure side, right? On the Azure side, in your shared services subscription, it's a very unique subscription because what you're going to have in the shared networking resource group, right? You're going to have a couple of artifacts in there. The first thing that you're going to have is a virtual network gateway. Now I'm drawing a line right through this resource group so as to indicate something. And I'll show you what I mean by that, right? So you're going to have two virtual network gateways, not one, right? And this line of separation, I'll speak to you in terms of what that is just now. Behind your gateways, you'll have your Azure firewall, right? I'm going to draw two instances, although you can't really manage them. And what these are, as much as they are actual physical devices, they're also VNet, they're also subnets. So this is a subnet of the, let's call this, right? Let's call this the transit VNet. So you need to have a transit VNet. So the transit VNet is all traffic egressing, ingressing, coming through, and these are the components that will actually make that up. And /24 is fine to be able to get your traffic routing through it. As far as I'm aware, this is a /27. This is a /26. And what you want to also potentially have is a management VNet. So I'll just draw a VM there. Management VM is if there's anything you need to manage. And that's possibly a 28. And remember I mentioned shared services, right? So shared services, in the shared services subscription, you want to put your identity, right? So identity is obviously your Active Directory, because when you deploy workloads to, let's just say, to app 1 here, and app 1 needs to be domain joined. That resource needs to have access to the Active Directory environment or your Kerberos environment. Now, Azure AD is not Active Directory, although the users and accounts, like here, what you will do, right? What you will do is probably this is an AD Connect server. Normally, most organization it synchronizes Azure AD, but this is Active Directory and this is Azure AD. So they're very different technologies. And when you domain join virtual machines, which I'll speak to you just now, if they need Active Directory, right? So your identity needs to be in shared services. And so what you can have instead of putting physical virtual machines for Active Directory, what you can do is you can install a PaaS service of Active Directory. And what that really does is it configures 2 domain controllers as a PaaS offering. So this is called ADDS. So Azure Domain Services, it's not Active Directory. It's a read-only copy of this Azure AD. And all it does, it's a one-way replication from Azure AD down to Azure Domain Service. Now, the benefit of that is you don't have to manage domain controllers, and it's obviously maintained. The infrastructure is maintained by Microsoft, but I have seen customers wanting to install their own domain controllers. You can go ahead and do that. So this is identity. In the very least, your shared services subscription should have a shared network, should have a gateway, definitely running resiliency. Remember, I told you about this line, right? That line is availability zones, or AZs. So availability zones are basically segments of a region that are split by about 20 kilometers apart, right? And so they have their own water, and their own cooling, and their own, pretty much it can, if one of the availability zones down, it theoretically doesn't affect the other availability zones. So you just need to keep that from a design standpoint perspective, right? That from an HA perspective, remember what I spoke about? HA is different with DR. This is HA. And when you're designing your workload, especially your shared services, you always choose the availability zone aware version of that. It's more expensive, but it allows, if this zone is taken out, that the second instance of the gateway will still keep that IP block running. And so what happens here is this is the express route, right, coming through, and that's the express route connection in there. And what it actually does is obviously connecting to the balanced IP. Very important to remember that that AZ zonal capability, and it's usually done at build time. So when you're deploying your workload, you have to select it during build time. Okay, so now what we have is we have the on-premise environment. We know what the network is. We have the shared services subscription. We've got the routing in place. We've got the firewalls in place. Now, how did we carve up the block? What is the best practice here, right? What is the best practice in terms of splitting up that block? Remember what I said, the customer's logical block is this. So what you want to do is you want to carve things up into /24s. And guys, there's all sorts of positives and pros to doing it this way. It doesn't mean that you can't do it the other way, that you create, you break it up into massive blocks and you just share it. And I'll explain the benefits of this. So let's just say what we do is we're now going to carve the /16 into multiple /24s, right? It basically means that we've got control over this octet, right? So on the transit VNet, what we're going to do is we're going to select the first octet, which is 10.200.0.0/24. So the transit VNet is going to be, let me just clean up here. So the transit VNet is going to be, right, there's going to be 10.200.0.0/24, right? So that's the first octet, usable octet, and each of the blocks for the gateway and the firewall and the subnets. What happens is when you create these respective subnets, like the Bastion subnet, what will happen is it'll take a chunk of this 24 block, and now so now you have a connection from your on-premise into shared services, right? There's a new technology that will help with complexity. So the technology is called Azure Secure Hub. So what that basically is, technically, if you do it today, service is not really available in South Africa yet. If you do it today, you'd have to manually configure these gateways, and you've got to manually configure the firewalls on the same VNet, and you've got to do some funky routing to pass all traffic coming in from on-premise to the gateway. If you go and you create an Azure Secure Hub, right? I'm just going to draw what the Secure Hub will contain. So the Secure Hub in Azure will take care of you needing to manage gateways, and it will take care of you needing to manage firewalls. So it combines the gateways and the files into one service called a Secure Hub. And all you need to do then, it's built on the virtual WAN technology, but the Secure Hub component is the firewalling. And what you really do is you don't need to worry about scaling. You don't need to worry about maintenance. You just manage the routing rules and you manage the firewall rules. So that's important. That is called Azure Secure Hub, ASH. Right. Let's take, and we'll kind of like just finish off with how do we bring in the application now? And how is that represented? Remember what I said, guys. Remember what I said. The benefit of a shared services hub is that central egress and ingress, which means none of these subscriptions will transit traffic out or even receive traffic in. There are exceptions to that, but that's from a management perspective. So let's take a look at the production subscription, right? Let's look at the production subscription. So now we've got App 1 and App 1 DR, and you potentially will have a whole bunch of resource groups that are containers for your workloads, right? So these square blocks are resource groups. This is a subscription. So what you want to do is, in your shared networking, what you want to do is you want to have all your VNets, right? All your VNets for all your applications contained in the shared networking resource group, because it's easy to manage. And so App 1's VNet is stored in shared networking, right? And keeping with the carving of the /16, what you do is you carve it up into a 24/24/24, right? So you're not creating one massive VNet. You remember what I said about implicitly routing by exception, because not all of these applications need to root back on premise. So why then have a completely routable network? You don't want to have a completely routable network. So by conforming with the customer's block, right, which is a 10.200.0.0/16, you simply carve up the blocks logically. You have to track those blocks, right? But you can consecutively just move up the octets. And what will a typical application look like from a design perspective, right? So you've got the network and the VNet sorted out. There's no connectivity back on premise. And what you want to do is, this is best practice, right? So what you want to do is, in that resource group, you want to carve up your application. Remember that whole availability zone line going across? Actually, it goes right across. Just remember that, right? AZs. So AZs don't automatically kick in. You'd need to design for it. And let's just say this is app 1, and app 1's an N-tier application, right? So it's an N-tier application. You more than likely will have a web server. You more than likely will have an application server. You might have more of them. And you've got a database, right? Whether it's SQL managed instance or whatever the database is. This is for you guys from an application design. This is your web tier. This is your app tier. This is your DB tier. All right. Whether or not something is a VM, you'd need to try as far as possible to stick to the segmentation. And these are also, so these are the physical resources. Let's just say this is a VM. Right? You've got 2 VMs operating, maybe running IIS on it. VM1, VM2, and you got VM1, VM2. Now on the virtual network, what happens is, right, so you got this whole /24 here. You'll have multiple subnets. So this will be a web subnet, this will be an app subnet, and this will be a DB subnet, right? So these workloads here, this VM here, will actually sit on this VNet here, and because it's in the web tier, will sit on this. Potentially could be a slash. You could carve it up into /26s or whatever it is. The benefit of that is this. You know, why not just create all the resources and dump it on this one VNet? And this is the reason. You want to control. Have some level of control of traffic. You know, you want to be able to control traffic going from the application tier to the DB tier, and you want to control traffic going from here to here. And what you can do by creating them as subnets, these are network security groups, right? So you have the ability to say, the database, I only want you to receive traffic coming in from the app tier. So you minimize the attack surface area if somebody penetrates the web tier. They can't implicitly, you know, get to the DB tier. And then in a nutshell, whether you use IaaS, whether you use a combination of PaaS services, that's a general rule of thumb, right? You'd need to kind of stick to that rule of thumb. Right, so we've got our application set up. We're almost at 6 o'clock. So we've got I'm gonna just end on this. We've got our application set up, and now we want to route back on premise. Remember what we said now. Remember what we said. Let's just look at the flow of traffic. Now let's just, this VNet is a 10.200.1.0/24, right? Remember we move up the octets. It's part of the big /16, and now we want to connect this VNet to the internal workload here. And like I said, everything is egressing and ingressing through that. Let me just change the color. Right. So what you're going to have is you're going to create a relationship between that VNet and that security hub or that traffic VNet, right? And that is called a VNet peer. And a VNet peer, guys, is using very advanced encapsulation technologies to basically bypass any routing and essentially put all networks on the same. So this subscription here, right, could be my subscription, my tenant, and I could very easily peer with another customer's VNet peer on the Azure high speed fabric. That's the technology. You obviously need to have access to the customer's environment to do that. So now we connected the VNets up, right? And basically what that basically means, you now have the connection in place, and if you have BGP enabled, the routes will propagate. On the client side, you don't need to do anything, because more than likely what you're doing is you're saying to get to 10.200.0.0/16, route everything to this network. And what it actually does, it'll find its way through to this environment, and the virtual network gateway through the peer will pass that traffic back. So that is how you connect. And by the way, very, very important. When you're deploying these workloads, right, by default, everyone deploys something with a public IP here, maybe here. You don't want to do that. So all of these workloads, the only thing that's external facing is this service, which means that somehow we have to we have to create a, because we got this network created up here, and let's just say this is the internet here, and there's a user there, right? And you want to expose your web service. What happens is that you will create firewall rules here, and you will do DNAT routing back to say, okay, because this is routed now, whatever this private IP is, it will use the firewall's external IP to route back. So essentially, in a nutshell, this becomes your central point for controlling traffic from on-premise, right, and also from the cloud. All right. So I don't want to get into any more detail than that. All right. So time is up. Are there any questions? We take one or two questions. What I will do in subsequent sessions is we will unpack this in more detail. We'll go through the other principles. But today I've just given you a rundown in some of the best practices into how to handle routing and security. All right, so what you guys can do is that we'd really appreciate your feedback. Please update the meetup group if you have any questions, if you didn't agree with something, if I got too technical, if I need to cover other areas. Please share that in the meetup group, and if we don't receive your feedback, we can't change the sessions to be more exciting.
So, Lawrence,
yes,
hang on.
yes.
So there is a question here from Nikita. How do I set up SSO between my on-premises directory and my cloud applications?
Okay, good question, right? Good question. So one of the first things you need to have in place, is you have, let's just zoom into this. You'll have your user accounts sitting on this. This will be your domain controllers. So that will contain your users, your groups, even your passwords. What you need to do is if you want to set up cloud native authentication, which is using OAuth or SAML, then what you do is you need to synchronize. You need to use AD Connect, right? So AD Connect, what it does is it synchronizes your Active Directory into Azure AD. What then basically happens is now your users and accounts and even passwords, if you do password hashing, will appear in Azure AD. Once you have these security principles, once you have these accounts in Azure AD, then you can create something called an enterprise application, right? You want to establish SSO. So somebody who wants to authenticate to an application using that username and password, you have to create an enterprise app in Azure AD. And that basically means that you select the type of authentication protocol you're going to use, whether it's OAuth or SAML or WS Federation. And essentially what happens is you tie that back to your application. When someone logs into your application, right, what will happen is during the OAuth process, if someone authenticates into this, the application knows how to redirect. That's the relying party. It'll redirect that request to Azure AD. And you'll normally see this when you're logging onto Office 365. You get redirected back to login.microsoftonline.com, you enter username and password, and it passes a bearer token across. All right. Thank you, ladies and gentlemen. I really, truly hope that you guys enjoyed the session. Please provide your feedback, and we'll see you again. We will advertise the next session on the Meetup group. Don't forget, my fellow MVP, Data and AI, Niels Berglund, is presenting on Thursday. Gordon will share that in the post. So we look forward to seeing you there. Thank you very much. Enjoy your evening.
Thanks, guys. Awesome. Thanks, Lawrence. It was great.
Cheers, guys.